In this lesson, we're looking at how you can prove that a quadrilateral is a parallelogram. So in 9.1, it was if something's a parallelogram, you've got all these properties. In this lesson, it's pretty much the exact same stuff, just backwards. So parallelograms have opposite sides are parallel. So if the opposite sides are parallel, then it's a parallelogram. That's the definition. Parallelograms have congruent, opposite sides are congruent. So if both pairs of opposite sides are congruent, then it's a parallelogram. So it's true both ways. That's really all this lesson is looking at. It's the same stuff from 9.1, the other way around. So if you know that those properties are true, then it's a parallelogram. So you can show that opposite sides are parallel. You can show that both pairs of opposite sides are congruent. Or if you know that one pair of opposite sides are parallel and congruent. That one's a little bit different. Both pairs of opposite angles are congruent, then it's a parallelogram. If the diagonals bisect each other, then it's a parallelogram. And if consecutive angles are supplementary, then it's a parallelogram. So it's most of the same properties from 9.1, using them in reverse order to know for certain that the shape's a parallelogram. So both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. One pair of opposite sides is both parallel and congruent. Opposite angles are congruent. Diagonals bisect each other, or consecutive angles are supplementary. If you have any of those facts about the shape, then it's a parallelogram. So looking at this figure, we have a shape that has four sides, and opposite sides are congruent. So based off of what we just said, yes, it's going to be a parallelogram. We are going to prove it by proving that opposite sides are parallel, and then we'll know it's a parallelogram using the definition of parallelogram. So we're going to prove that the opposite sides are parallel. So to do that, we're going to be using things like alternate interior angles, corresponding angles, whatever we want to use, whatever works out for our proof. So first we're going to draw DB, because you can draw a line through any 2 points. And of course, DB is congruent to itself. That's called the reflexive property. AB was congruent to CD, and AD was congruent to CB. That was given. The diagonal we drew split this into two triangles, and now those two triangles are congruent because of side, side, side. Now, since the triangles are congruent, we have the angles ABD congruent to CDB, because those are corresponding parts of those triangles. Also, ADB, this angle over here, is congruent to CBD, because those are also corresponding parts of congruent triangles. Corresponding parts of congruent triangles are congruent. So since ABD and BDC, they form this Z shape. That's how we can easily identify alternate interior angles. Those are alternate interior angles. They are congruent, so that means the top and the bottom of our Z, AB and DC, are parallel. You can do the exact same idea, except talking about these two angles, which would be the top and the bottom of the Z shape. So AD and BC are also parallel because of alternate interior angles. So if opposite sides are parallel, then it's a parallelogram. That's the definition of parallelogram. We're going to look at another one of those theorems. We're going to go through the proof of that as well. We are given angle A and angle C are congruent, angle B and angle D are congruent. We're going to prove it is a parallelogram. So we have our statements and our reasons. So we could start by writing the given. There'd be nothing wrong with writing it now. I'm going to wait and write it in just a minute when I think it'll make a little bit more sense. And we're going to start with a basic fact that we know about parallelograms, and that is the four angles add to equal 360 degrees. The measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equals 360. And the reason is the interior angles of a quadrilateral always equal 360 degrees. Always sum to equal 360 degrees. So now I'm going to write angle A is congruent to angle C and angle B is congruent to angle D. That was given. So if they are congruent, that means they're equal. The measures are equal. So we can do some substitution here. We can replace angle C with angle A. Instead of the measure of angle C, we're going to write the measure of angle A because they are congruent. Similarly, instead of writing the measure of angle D, we're going to put measure of angle B because they are congruent or equal. So our reason right there is just substitution. So if we do a little bit of algebra, you have 2 times the measure of angle A and 2 times the measure of angle B, which means we could divide everything by 2. We just want to split this in half since it's all the same thing. We could just say the measure of angle A plus the measure of angle B equals 180. And that's just with a little division, dividing everything by 2. So angle A and angle B, if these are the parallel lines, then angle A and angle B are same side interior angles, and they add to 180. So that means that those lines are parallel. AD is parallel to BC because they are same side interior angles. If we would have done the substitution in this line just a little bit different, we would have kept angle A and D instead, which we can do. We just have to replace B with a D instead. So we go back to the original thing that we wrote, measure of angle A plus the measure of angle, instead of doing B, we're going to do D because they are congruent, we can substitute. Plus the measure of angle A plus the measure of angle D. Same as before, that was substitution, we're just doing it a little bit different way. Or we could have just gone to this line right here and substituted, instead of B, we could have put D in there and substituted that. Either way, we get the measure of angle B, or measure of angle A plus the measure of angle D equals 180. Could have saved a line if we wanted to. It's division just like it was before. Which means those are now our same side interior angles, which means AB and DC are parallel. Again, they were same side interiors. So we had the left and the right were parallel, we had the top and the bottom were parallel. That means that A, B, C, D is a parallelogram. You could say definition of parallelogram, you could say opposite sides parallel, either way would be fine.